Welcome back. Let's resume trigonometric equations. In the previous video, we went through the grand summary for sine equation, for cosine equation, and for tangent equations. And then we went through these two problems, sine equation and cosine equation. Well, we have sufficient time, so let's talk about the third example as well, tangent equation. It looks like sine and cosine because there's no tangents there, but it turns out to be tangent. And one way to handle it, move this cosine part to the other side. We get 2 sine of x is negative 3 cosine of x, and then divide both sides by cosine. We have sine over cosine is negative 3 halves. Because sine over cosine is tangent, we get tangent of x is negative 3 halves. That's basically it. We take the arctangent. Arctangent of negative 3 halves plus k pi, because period is pi, excuse me. Do we have visualization here? It's kind of like this one, but that's a bit too simple, not that interesting. Okay, let's move on to a little bit higher level problem, quadratic or higher. Let's begin with the easiest type. We have just standard sine equation. Everything is sine. We have quadratic sine and then linear sine and then constant. In this kind of problem, standard technique is just factor, and it's not going to be too bad. You can use tic-tac-toe or whatever, then you can see that 6y squared minus 5y minus 4 is equals to 2y plus 1, 3y minus 4. Just like that, we can use that for sine function. Consequently, you're going to get the factorization we see below, 2 sine of x plus 1 times 3 sine of x minus 4. Setting the first factor equal to 0, we get sine of x equal to negative 1/2. Taking the second factor equal to 0, we get sine of x equal to 4/3. Now, do both of them make sense? I hope everybody sees this. The second one, sine of x equals to 4/3, is bogus. The reason is because sine function is bounded by negative 1 and positive 1. Here's a graph of sine function, by the way. Where is it? Here. Going up and down between negative 1 and positive 1. But 4/3 is outside this oscillation. So this oscillation will never reach 4/3. So that's an extraneous solution. Throw that away and work out only sine of x equal to negative 1/2. You can take arcsine of that and use your calculator, but this is actually a standard angle. Excuse me. So you can use a trig diagram to figure out. I'm talking about something like this. In this diagram, the first coordinate is cosine, second coordinate is sine. So when do we have negative 1/2? 7 pi over 6 and 11 pi over 6. Those are two standard solutions, solid dots in the visualization in the previous video, and then plus 2k pi. If you use calculator or some computer algebra system, then you're going to get negative pi over 6 as standard answer from arcsine. Pi minus of that is automatically answered, so we have 7 pi over 6. If you use that trig diagram, 7 pi over 6 and the other was 11 pi over 6. So we have, well, alternative way to write the same thing. What's the difference between 11 pi over 6 versus negative pi over 6? Negative pi over 6 plus 2 pi is 11 pi over 6, and k is arbitrary integer. So by adjusting k value, everything will be covered. Let's see, do we have a justification here? Yes, we have it here. The solid red dot is negative pi over 6, which is actually arcsine of negative 1/2. And then the green dot is pi minus of that. And those red and green dots are reproduced in the next period as we move to the right. And then if we continue moving, then we have another pair, another pair, another pair to the right, and then the left as well. All those are captured by these 2k pi's. Okay, let's go over to a cosine equation this time. And cosine equations are generally easier because instead of pi minus of the solution, we can simply take negative of that. Let's work it out. You can factor the given polynomial equation. 5 cosine squared minus cosine minus 4 is equal to 0. And you can factor like this. I'm going to leave the factorization to you. And then taking the first factor equal to 0, you're going to get cosine of x is negative 4/3. Taking the first factor equal to 0, we get cosine of x is equal to 1. Now from this one, you can take arc cosine of negative 4/3, and negative of that is also an answer. And you can do the same thing here. Arc cosine of 1, which is 0. Negative of 0 is 0. So, well, in this case, arc cosine of negative 4/5. Negative of that, we have those two. We have those pair. But in this case, 0 and negative 0 will not make any difference. As a matter of fact, those pair of points collided each other at the top, at the peak, and we have just one solution. Here's a visualization, by the way. The red one is the first solution. And then solid green on the other side, in the far left-hand side, is this one. And by adding 2k pi, those red and green dots are being reproduced a little bit to the right, and then a little bit to the right again, also to the left. How about cosine of x equals 1? In that case, we have 0 plus 2k pi, and that's right on the y-axis. We have black solid dot. And then by adding 2 pi and then 4 pi and so on, we have the copies of those hollow black dots to the right. And then to the left, we have the same thing. Here we had pair of points, red and green. Here we have just one. The reason is because these two, red and green, collided at the top of the mountain, and then it became just one solution. The same thing will happen if they collide at the valley. In this particular case, it was the top of the mountain. Cosine of x is positive 1. Okay, we just went through a couple of standard, the easiest type of equations. Now let's move on to a little bit harder one. 3 sine squared minus 4 cosine of x is equal to 2 cosine squared of x plus 2. It looks intimidating because sine and cosine are mixed up. And consequently, how do we set up as a quadratic equation of sine or cosine or something else? Well, in this kind of problem, I'd like to give you 2 reminders. Reminder number 1 is this. Cosine squared of x plus sine squared of x is equal to 1. Consequently, we can write, cosine squared of x can be rewritten as 1 minus sine squared of x, or sine squared of x can be rewritten as 1 minus cosine squared of x. And basically what we do here is change cosine to sine, or change sine squared to cosine squared. From this identity, which we call Pythagorean identity, or I frequently call it the formula number 1, because this is by far the most important formula in trigonometry, at least in my opinion, we can see that cosine squared and sine squared are interchangeable. So we can change one to the other. Now, How do we apply it here in this problem? Do we change sine squared to cosine squared, or cosine squared to sine squared, or do we do both? Well, you have to have a certain sense of direction. We have a tool here, but we have to have sense of direction, and that's answered by the linear term, cosine of x. This quadratic term here, sine squared, and that quadratic term here, cosine squared, are interchangeable. But this one in the middle, we can't change that one. So that dictates the direction of the problem. So let's make this observation. Let's highlight this one in bold red. And because of that, we have to change into cosine. Okay, we want cosine. The right hand side is already cosine squared, no problem. The left hand side we have sine squared, that's a problem. So let's substitute it with 1 minus cosine squared. And as you can see, I did the color coding in advance. The sine squared is now rewritten into 1 minus cosine squared. And if you look at the second expression, everything is cosine. So we have a quadratic equation of cosine. Now we're in business. It's pretty much the same as problem B we just did. Okay, let's manipulate this algebraically. Break up all the parentheses. Take the like terms together. And if the first leading coefficient is negative, I usually don't like it. So multiply -1 to both left hand side and right hand side. Change all the signs. And -1 times 0 is 0. So right hand side we have no change. Now we have a little bit easier factorization. And we have first factor, cosine of x is 1/5. So we have 1. And cosine of x is -1. We have the second. From cosine of x is equals to 1/5, we are going to get a couple of solutions. Cosine of x is equal to -1, we are going to get one solution because those two solutions collided at the valley pit. And here are the results. Cosine of arc cosine of 1/5 plus 2k pi, negative of that plus 2k pi, and then arc cosine of -1 is pi, so pi plus 2k pi. And then negative of that is negative pi, but that doesn't make any difference because negative pi plus 2 pi is pi, so it's absorbed by this 2k pi. By the way, here's a graph. The solid red and solid green dots are, as usual, arc cosine, which is solid red, and then negative of that, solid green. And then solid black is x equals to pi. And then after that, we simply take plus 2k pi to reproduce all those in the next interval and the next interval and so on. All those are represented in the same color but hollow dots, blue, red, and green. And then to the right, again, blue, red, and green. To the left, we have blue, red, and green. Looks like I'm missing one hollow green all the way to the right hand side, I guess. Okay, everything is now well represented here. Everything is fixed now. And here is the solution. Here's the picture. And here is the algebraic solution. We have to have a certain sense of direction. I cannot emphasize that too much. That's given by the first order term. That's why I highlighted this cosine of x into red. And then consequently, this one's okay, and then change this one into cosine squared using the Pythagorean identity. That was a typical technique.